In this video, I am going to show you how you can access and use large language models in Google Cloud's Vertex AI by using this AlloyDB Omni. AlloyDB Omni is your locally deployable Postgres database, which is a replica of AlloyDB service in Google's cloud. So in other words, what is happening here is that Google allows you and enables you to deploy a cloud database which is Postgres compatible onto your own local system. It could be on your laptop or it could be in any other cloud. It is primarily a simple Postgres SQL database. Now in this video, what I'm going to do is I'm going to call the large language models hosted in Vertex AI in Google Cloud Platform from within the database and then using database own data to call that large language model and then update the database. The power of this functionality is that now you can integrate your existing data within your databases with the data produced by large language model, or you can use your existing data to get more tailored and customized information from large language models, or in other words, this is a type of retrieval augmented generation or RAG. I already have installed AlloyDB Omni on this Linux instance, which is Ubuntu based. And if you don't know how to do it, I just did another video as how to install this AlloyDB Omni and integrate it with Vertex AI just today. And I will drop the link in video's description with all the commands. So let's suppose you already have that installed on your system. And for me, I'm using AWS EC2 instance, which is simply R6i instance. And as you can see, I am already logged into my Postgres system. Now let me show you step by step as how you can create a new database in this AlloyDB Omni and then how you can integrate this AlloyDB Omni with a large language model hosted in Vertex AI. Let's get started. The first step I'm going to do is to create a new database. The command is simple in Postgres create database bison1. Bison1 is the name of my database. You can select your own. That's done. Let's see if it was created /l. So these are all the databases currently present in my Postgres or AlloyDB Omni instance. This is the new database which we created. Let me clear the screen with Control capital M, Control capital L, sorry. Now that's done. In the next step, let me quickly show you the connection information. So /con info. So right now I'm connected as Postgres user to my Postgres database on this local host. And we just created Bison1 database. So let's switch to that Bison1 /c Bison1 and now run that con info again. And now I'm connected to database Bison1 as Postgres user. Let me clear this screen again. Now let's create a dummy table called as books in this new database. So, and this is a simple DDL or data definition language command where I'm creating a simple table books with primary key ID and then few other columns, and couple of them are not null, so you have to provide a value there, and then I have two other columns. Now let's insert some dummy data into this table with simple insert command, which is a DML command. That is done. And let's select static from this table just to see what's inside. Let me clear this and then show you again. So this is all the data. So this table contains 5 rows. There's a title column, which is the title of the book, and then we have some other information like description. Let me only select title and description because rest of the columns are empty. So this is all I have in this table. Let me clear it again. Now, before you could start using LLM with this data, let's install the extension first. Extension allows this AlloyDB Omni to talk to the Google machine learning algorithm. So command for that is simple: create extension, Google ML integration cascade. Cascade means that if there is any other integration required, it will install it, such as in this case vector. So it installed everything. Now let's give execute right on this ML predict row function to this user. And if you are if you know about what LLMs are or large language models are, all they are doing it is they are predicting the next word. So this is the function which we call with the model to predict what exactly we want it to predict. Okay, this is cool. So this is all you need to do in order to to prepare your database to talk to Vertex AI model to generate some generative AI text for you. Let me clear my screen. Now let me show you something really cool. So if you remember, this is my table. Let me quickly show you my table rows. So these are all the titles like wildfire, ikagai, and stuff. And in this query, what I'm doing here is I am selecting title, and then I am calling that function ML predict row, and I'm giving it this text bison model, which is a Google supplied model, which is used for text generation. This is the name of that LLM, text bison. And then I'm passing it the prompt, and I'm asking it, can you create a summary for this title? And this title is replaced by this database columns field, Lola in the mirror or whatever. In our case, I'll show you what. And then I'm asking it, can you create a summary for this title based on following description? And this is a description column I'm selecting. And then I'm asking it how many tokens I need from this. And then I'm asking it to predict it. And this is a table I'm selecting, and I'm only selecting it for my title wildfire. So I'm asking it to give me a summary of this title, this book. And you can see that in our database, the summary is not present. And we are creating the summary on the basis of this description. So let's pass it to the LLM and see if LLM is able to generate the summary or not. I have pressed enter, and let's wait for it to return the results. There you go. So it has gone out and it has given me the summary of that title. How cool is that? Now let's try it out with another example. Now instead of okay, so now let me ask it another question. So instead of asking it to generate the summary, I'm clearing my screen. I'm asking it to give me the author of that title. Now, if you remember, let me show you. If I go and I say title and author, there is no author in our database. So our database is not aware of the authors. So if I don't know it, let me ask this LLM to give me an author. Let me, so you can see here, I'm asking it in the prompt, who is the author of this book and then title. So let's see. There you go. So it has given me the correct author, Kathleen and Gunan, who is the author of this wildfire. And similarly, you can ask it the author of any other book title from your database. Now, what I want to do is I want to pick this author and update my database. For example, if you have already have an existing database with millions of book titles in it, but you don't know who the author is. Now you want to update the authors. One way is to just manually go and find the authors of all those books, maybe put it in some CSV file and import that data into CSV, or write some really complex code which will go into some book stores API like Amazon, pull out the book title, massage it, clean it, and then put it in this table somehow. Now, instead of doing that, we will ask this LLM to give us the author, and we will update the table, this books table, with that information. And we can do it with simple one query. And let me show you how. I'm using simple update command with this. Let me put it properly. I think this is. Let me clear it first. Sorry. Okay. Now what we are doing it, we are. Let me put the command here and I'll explain. Okay, so first we are, it's just going into the other line. I'm just fixing it. Okay, now there you go. So what I'm doing is I'm updating the table book. I'm setting the author, and author is I'm just taking the author from LLM. And if you look at the prompt, this is my prompt. Only return exact name of author of this book, title, and no other text at all. Because if you remember in our previous prompt, it was also returning the full sentence like the author of this book is and the author name. We don't want it. We only want author name. So we have asked LLM to do that instead of going into the output and taking and doing substring and other complex things. We are simply asking LLM to do it. And once we ran it, you can see that it has updated the row. Now let's go into a table and see what happened. There you go. Only the author name has been updated in the table. How cool is that? So you can see the power of LLMs here once they are integrated with your own data in the database. And I'm not doing anything fancy. All I have done is I have simply ran a query with this predictor function, which has invoked this text bison model from Google, which is hosted, and then it has returned me the result. I haven't installed any model. I have not configured anything machine learning. I have not done anything fancy with generative AI. All I'm doing it calling this function with proper parameters, and I have adjusted my prompt to make sure that I get the result what I want. So you can appreciate the power of this. I'll be doing more videos on it because I really find it that very useful. We can implement it today easily in our lot of applications without going into the mumbo jumbo of all this hype around generative AI. If you have any questions, please feel free to ask. And if you like the content, please consider subscribing to the channel. And sorry, one last thing, all these commands, don't worry about copy pasting them. I'll put them in my blog and I'll drop the link in video's description so you can just copy paste and use it. Thank you very much and have a good day. Bye.